Hi everybody. Today we're going to be talking about how to use a prefix table in order to help us with our unit conversions. This prefix table given here is not an extensive list, which means there's not going to be every single prefix you may need to know in the metric system. But here is the example of what we're going to be using today. And the prefixes are on the left with their abbreviation in front of their unit, and then the value associated in relationship to the base unit. And this is what we're going to really be focused on here today. We're going to be using the prefix table to find the conversion factor between two different units with the different prefixes. Let's start with some practice. If we want to find the relationship between, let's say, a gigahertz and a hertz, the way that I'm going to be teaching this is just a way of making it easier for everybody so we never have to deal with any negative exponents. And what I mean by that is if we follow this process, we're going to write them both on the side of an equal sign, and we're going to put a 1 in front of the bigger unit. So we have to ask ourselves, what's bigger, 1 gigahertz or 1 hertz? And if you don't know exactly what the units mean yet, if you look on this list, the higher it is on this list, the bigger it is. So we're going to put a 1 in front of a gigahertz. And on the other side, we're going to write 10 to the power of a number. And this number is going to be determined by the relationship between gigahertz and our base unit. And the way that we find that, it is going to be the distance between the exponents of our units, or of our prefixes. So in this case, giga is 9 for the exponent of their 10, and the base unit is 0. So the distance between 9 and 0 is just going to be 9. So 1 gigahertz is equal to 10 to the 9th hertz. But now let's try it with two different units, or two different prefixes. Let's say we want to find the relationship between a terameter and centimeters. So now, following the same methodology as before, we're going to put a 1 in front of the bigger unit. And since tera is higher on this list, we're going to put a 1 in front of terameter. And then we're going to put 10 to the power of a number for centimeters. And again, this number is going to be the distance between the exponents of the 10 for each individual unit. For tera, we know it's 12 due to the list, and then centi, it is minus 2. The distance between 12 and minus 2 is just going to be 14. So 1 terameter is equal to 10 to the 14th centimeters. Again, if you do it this way, where you put a 1 in front of the bigger unit, you will always have positive exponents for your smaller unit. Keep that in mind. Let's go to some practice problems. Here is an example of a problem where you're not given a conversion factor because you should be able to find it using your information from the prefix table. A wave has a frequency of 1.5 gigahertz. What is this in units of hertz? Now, we just found the relationship that 1 gigahertz is equal to 10 to the 9th hertz. And that's exactly how we would use the prefix table to get the conversion factor that wasn't given to us in the problem. So now, since we have the conversion factor, we can actually write out our table, or our fence table here, where we have our information of 1.5 gigahertz, and we want our final answer to be in units of hertz. So the relationship that we have to use to cancel out gigahertz is put the 1 gigahertz on the bottom and put 10 to the 9th hertz on top. With this, our gigahertz cancel out and our hertz retain, which is what we want. And so the final answer is going to be 1.5 times 10 to the 9th hertz. And that is the relationship between hertz and gigahertz. A car drove approximately 35 kilometers in the past hour. What was this distance in centimeters? So here we need to find the relationship between kilometers and centimeters. So we write out a conversion here, kilometers and centimeters. We're going to put a 1 in front of the bigger unit. And kilometer, we know means 10 to the third, and centimeters means 10 to the minus 2. And so we're going to put a 1 in front of kilometers, 10 to the power of the distance between 3 and negative 2, which is going to be 5. So 1 kilometer is equal to 10 to the 5th centimeters. Now with the conversion table, we're going to put 35 kilometers in the top, and we want to find a way to cancel out kilometers and convert it to centimeters. And that's exactly what the conversion factor that we found above. We're going to put 1 kilometer on the bottom, 10 to the 5th centimeters on top. Our kilometers will cancel out, and we'll have units of centimeters for our final answer. And then in proper scientific notation, which we'll cover in a later video, it is going to be 3.5 times 10 to the 6th centimeters. For our last example problem here, what is the concentration of a 7.41 millimole per milliliter solution in units of moles per liter? So, as we can see here, we're trying to go from millimole to mole and also milliliter to liter. They both have the same prefix unit going to the base unit. We're going to write out our conversion factors over here, mole and millimole, and liter and milliliter. We know the base unit is larger than milli, so we're going to put a 1 in front of mole and liter. And the distance between the base unit and millimole, the distance between our base unit and milli is 10 to the 3rd power. And so we're going to use that for both from base unit to milli. And so these are the conversion factors that we actually need in order to convert from millimole per milliliter to mole per liter. And that's when we write out in our table 7.41 millimole per, and so we'll put that on the bottom, milliliter. And so let's work on canceling out the millimole first. So we're going to put 10 to the 3rd millimole on the bottom is equal to 1 mole on top. And so millimoles cancel out, and we're left with units of moles in our numerator. If we continue our conversion, we need to go from milliliter to liter. And so we're going to put our 10 to the 3rd milliliters on top and 1 liter on the bottom. In this way, our milliliters cancel out, and we're left with units of moles per liter, which is what we want. Now, with rules of fractions, anything on the top and the bottom we can cancel out like we did with our units. But we also see we have 10 to the 3rd in the top and the bottom. So we can actually cancel them out. And so the final answer is just going to be 7.41 moles per liter. So it has the same quantity, just for a different representation of units. I hope you learned something from this lesson today. Please check out my channel for more chemistry practice problems, and please like and subscribe.